Okay, so up to this point, we've looked at regular permutations, which we can express as subscript n, p subscript r is equal to n factorial divided by n minus r factorial. Then we've looked at when we've had repeating objects, so that when we just look at n exclamation mark or n factorial, and it would be the number of times each case occurs. So it would be a factorial, b factorial, c factorial, and so on, depending on the number of repeating objects that happen in that scenario or the problem. So now what we're going to look at is we're going to look at arrangements requiring cases. So to solve problems, you must count the number of different arrangements in all the cases that together cover all the possibilities. So here we're looking at different possibilities. To calculate it, you calculate the number of arrangements for each case. So you calculate the permutations for that specific case, and you do that for each one, and then you add all of those permutations together, and that is your total number of arrangements. And whenever you encounter a situation with constraints or restrictions, your number one thing to do is address that choice with the restrictions first. So we're going to look at some examples of what on earth this might look like. So just as maybe as I can give you a little hint, you might know that this will have different cases. Usually there's some key words, say such as maybe they say at least a certain amount, or maybe it's a minimum. Could be a maximum. Or could be words like that where it requires a certain number, but it could also be more, it could also be less. And so what you're going to do is you're going to find those permutations for each of those and then work from there. So we're going to look at first an example. So this one here is not so obvious. It's a little bit harder to see what happens, but typically this one here will be one of your more harder, I guess, ways to identify that there could be multiple cases. Other than that, you will be dealing with word problems that deal with the words at least, minimum, maximum. So it'll be a little bit more obvious in your homework. Okay. So in this first example here, we have how many different 3-digit even numbers greater than 300 can you make using the digits 1, 2, 3, 4, 5, and 6, where no digits are repeated. So you must use all of those digits. So in this case, we're going to have two different cases. And at first it might not be so obvious, but as we work through the example, we're going to see exactly how this becomes two cases. So here, first case, so here we have two cases. And the first case is when we start with, and that's going to be an even number. And it's very important, our even numbers, it can include 2 because then that digit would be less than 300. So it's only going to be 4 or 6. And then our second case is when we have even numbers. So it starts with, when it starts with an odd, which would be 3 and 5. So remember, don't include 1 there because then it'd be less than 300. So our first case is when it starts with 4 or 6, and then our second case is when it starts with 3 or 5. So here we have a 3-digit number. And so this one, it has to be an even number, and here we're also saying that it starts with 4 or 6. So here, if we could start off with, this one here could be 4 or 6. So that means that there's 2 different options. Then from here, it could be a 4, 6, or 2, depending on what you picked on. But you have already picked an even number, so that means that when we pick this number, there's only 2 options left. So this one has to be a 2. So then what is left over for our middle number? That one could easily be, I guess, if you want to take the total. So there's 6 numbers there. You used up 2, so that means that there is 4 left. So we could pick from any 4 of those numbers. Whichever ones we didn't use, that is the choices that we have that's left over. So that means here we have 2 times 4 times 2 different ways to, I guess that we can have 300 or some number greater than 300. So that'd be 2 times 4 is 8 times 2 is 16. Just going to scroll on down a little bit. So now starting with, in our second case, so what happens if it starts with a 3 or a 5? So here we have our 3-digit number. And here we have that it starts with a 3 or a 5. So here there's 2 choices there. Then for our, to end it has to be an even number. So that means that we can only have 2, 4, or 6. And we haven't used any of these yet, so we could really pick any of these even numbers. So here we could have a possibility of 3 different choices. And then, just like last time, we used one here, we used one here, so that means that there's only 4 left to choose from. So that means that there's 4 different ways. So now what we can do is we multiply them together, and that'll be our, I guess, the number of ways that we could write a 3-digit even number starting with a 3 or a 5. So that'd be 2 times 4, which is 8, times 3 is equal to 24. Now if you go back up, if you remember, so it says to calculate the number of arrangements for each case and then add the values for all cases to obtain the total number of arrangements. So the key word there is now that we've already calculated the number of arrangements, now we add them together. So here we have, I'm just going to write it up here, we have 16 plus 24, so add them together. So that means that there is 40 different ways to write a 3-digit even number that is greater than 300. Okay? Okay, so you guys can go ahead and get started on your homework. And one key thing about this unit that I cannot stress enough is doing your homework. It may be hard to recognize the cases, but this is only going to come with practice. So please, please do your homework and have a great day.